es el doctor Lucio Soibelman. Y va a hablarnos sobre su perspectiva sobre similitudes y diferencias entre industria y academia. His perspective on similarities and differences between industry and academy. So, Lucio, the floor is yours.
Thank you. Thank you, Jorge. First of all, I would like to thank for the honor of being elected a member of this academy, for the people that nominated and voted for me. Second, my talk, it's going to be, again, a reflection of a personal journey. So I was born in Brazil, in southern Brazil, border with Argentina. And as I said, from a very dysfunctional family. My dad is an engineer. My mom was an engineer and an architect. My three older sisters are engineers and computer scientists, married to engineers. So all my life, engineering has been the core of everything. I never had vacations on Disney. Vacations for me was to visit Itaipu construction or big sites or nice buildings and other types of constructions. So from that, I started working in construction and engineering extremely early. My father has a construction company, and my high school was next door almost to his office. So after school, I would go to his office and I would start working with him, learning a lot that the basic for his job was a lot of knowledge, a lot of experience from his past experience. And this has been driving me, and it's going to be back in the end of my concerns and what's happening today. From that, I started my first company still when I was an undergrad in engineering. I had a wood structure company. And after graduation, I had my own construction company for around 10 years in Brazil. And the issue is that at one moment, I realized that I was moving from engineering to management. So I was managing engineers, but my job was to sell projects, to bid for projects, to run to banks, to deal with suppliers, and very little engineering. And I was a little bit frustrated with that I wanted to do engineering. I loved engineering so much. And then another thing that was driving me at the time was being in Brazil. I had the feeling that the construction sites were dirty, dangerous, productivity was low, that there was better ways of doing things. So at that time, I decided to close my company and came to the United States to get my PhD at MIT. And obviously at MIT, no one cared about construction at all. They cared about computer science. So I ended up doing my PhD around 30 years ago in machine learning, AI, and implications of those things in engineering and structural design. And after that, I got my first job as a professor at University of Illinois, Urbana-Champaign. And again, that I was doing real engineering. I was solving problems, using my knowledge in engineering to come up with solutions for problems related to the research that I was working. But with time, things start changing because I got a much larger research group. I got a lot of PhD students and I was working with big data in construction and moved to Carnegie Mellon to work with the smart buildings, smart infrastructure, smart bridges, sensors, and streaming data. But at that time, my research group was so big that I learned that I was doing the same thing that I did in industry. I was managing research. My job that in industry was to get money from clients, change it to get money from government agencies to keep my research going. That I was really moving into management, and that moved even more when I came here to USC, University of Southern California, as a department chair, managing 700, 800 students and 50 faculty, 100 staff. So what I learned it's that a lot of we do as engineers, when we start to excel, we end up moving a lot from engineering to management. And but we cannot lose our focus that we are engineers. So we have to find a way to go back and spend at least 30, 40% of our day in engineering, really solving real world problems. So this, I thought that it's I claim that it's the similarities that in my life, both from academia and industry, is that in the end, we really have to put an effort to focus in doing engineering. And this is something that today it's even more important. It's what I call about lifelong learning and keeping our knowledge updated. Engineering is changing extremely fast, and you can get obsolete in days now if you don't catch up and understand what's going on. We are living today in something that keeps me awake today, is that we are living what I call an inflection point. We have this current fourth industrial revolution bringing together the physical and digital worlds. We as engineers, I really like something said by aerospatial engineer Theodore von Karman. He said that science describes the world as it is. Engineers create the world that never was. So we have been, during the last several hundred years, we've been creating the world that never existed. We've created buildings, bridges, machines, automobiles, and everything in the physical world that changed the world. But today you are creating the digital representation in parallel to that physical representation. So we are creating a copy of this physical world and adding to it intelligence with machine learning and AI. So now we are creating a new change in what we call the knowledge economy. We have been developing the machines that have been replacing labor, replacing workers, muscles, since the agricultural manufacturing of fabrics in Europe with the Industrial Revolution and robotics today that are replacing workers. But for the first time, now we are going to replace ourselves. We are starting to replace knowledge technology, the knowledge economy. And a lot of jobs will disappear. And as an educator, you have to be I'm very, very concerned with the direction that you are moving. We really need to teach what computers cannot do. We need to teach, for example, creativity, flexibility, negotiations, and things that we still outperform computers. We need to learn how to compete in a labor market in which brilliant machines will work alongside us. And we need to improve our data literacy, big data, technology literacy in teaching coding and engineering principles, and what I call human intelligence, teaching humanities, design, communications. So we are, as I said before, in that inflection point. When I came at the beginning of the talk, talking about my dad that had all that knowledge, that used the knowledge and the experience, a lot of these now can be replaced by big database from productivity in previous projects, cost in previous projects. So how do we optimize and teach this new generation of engineers, and how do we keep ourselves updated, not to end up obsolete? It's something that keeps myself awake. A lot of work in rethinking curriculum, and a lot of work in rethinking how you're going to educate this new generation with the new tools and new things that we are facing today. So I think that the journey is that, and the reality is that this is impacting academia, education, and industry and companies, and we need to get together and rethink the future of engineering. Thank you very much.